5 fascinating facts about our Sun. 1. It's a massive star. Our Sun is a colossal ball of gas, so big that it accounts for 99.86% of the total mass of our solar system. You could fit about 1.3 million Earths inside it. 2. It's incredibly hot. The Sun's core reaches temperatures of around 15 million degrees Celsius, 27 million degrees Fahrenheit. That's hotter than anything we can imagine on Earth. 3. It is middle-aged. At around 4.6 billion years old, the Sun is roughly halfway through its life cycle. It's a stable main sequence star now, but in about 5 billion years, it will expand into a red giant before eventually shrinking to a white dwarf. 4. Produces solar wind. The Sun constantly emits a stream of charged particles known as the solar wind. These particles interact with Earth's magnetic field, creating stunning auroras, like the northern and southern lights. 5. It is the source of life. Without the Sun, life on Earth wouldn't exist. Ever wondered what would happen if a basketball-sized asteroid slammed into our planet? Even a small asteroid travels at speeds of up to 45,000 miles per hour. Upon entering our atmosphere, it would create a spectacular fireball, lighting up the sky as it burns. Most of the asteroid would disintegrate due to the intense heat of atmospheric entry. However, if any fragments made it to the ground, the impact would be similar to a powerful explosion, comparable to a small bomb. While it wouldn't cause global destruction, the impact site would experience significant damage. It could shatter windows, cause fires, and leave a small crater, but the effects would be localized. Thankfully, space agencies around the world constantly monitor the skies for any potential asteroid threats, big or small. 5 jaw-dropping facts about Jupiter. Number 1. Jupiter is the king of our solar system, more than 11 times wider than Earth and so massive that all the other planets could fit inside it, with room to spare. Number 2. This colossal storm, larger than Earth, has been raging for at least 350 years. Imagine a hurricane that never ends, with winds tearing through at over 400 miles per hour. Number 3. Jupiter has the most powerful magnetic field of all the planets, 20,000 times stronger than Earth's. It creates intense radiation belts that could fry electronics on a passing spacecraft. Number 4. With 79 known moons, Jupiter has a mini-solar system of its own. Number 5. Jupiter is mostly hydrogen and helium, just like the Sun. If it were about 80 times more massive, it could have ignited into a star, making our solar system a double star system. Saturn's rings are made up of billions of particles, ranging from tiny ice crystals to massive boulders, all orbiting the planet at incredible speeds. These rings aren't just a single band, they're divided into 7 main rings with countless smaller ringlets. Their bright, shimmering appearance comes from the way they reflect sunlight. Saturn's moons play a crucial role in shaping the rings. They create gaps and waves through their gravitational pull, leading to the ring's intricate structure. The Cassini spacecraft provided us with breathtaking close-ups of the rings, revealing details never seen before. The rings are in constant motion, creating a mesmerizing dance of ice and rock around Saturn. They remind us of the dynamic and ever-changing nature of our solar system. What happens when 2 black holes collide? When 2 black holes get close, they start an intense gravitational dance, spiraling around each other at incredible speeds. This tango can last millions of years, pulling in nearby matter and distorting space-time. Eventually, the black holes collide with mind-boggling energy, merging into a single, even more massive black hole. This collision releases enormous amounts of energy in the form of gravitational waves, ripples in the fabric of space-time. These waves travel across the universe, carrying information about the black hole's masses and spins. Scientists detect them using observatories like LIGO and Virgo, providing insights into the mysteries of the cosmos. The newly formed black hole quickly settles into a stable state, but the surrounding space remains turbulent for a while. The merger can also result in a powerful jet of particles being ejected at nearly the speed of light. Ever wondered if shortcuts through space exist? Enter the mind-blowing world of wormholes. Imagine folding a piece of paper in half and poking a hole through it. Suddenly, 2 distant points touch. That's a wormhole, a theoretical tunnel connecting far-off corners of the universe. While wormholes sound like pure sci-fi, they're rooted in Einstein's theory of relativity. Think of them as cosmic shortcuts that could slash travel time across galaxies. If wormholes exist, they could unlock mysteries of time travel, parallel universes, and beyond. But beware, Navigating one might be a wild, unpredictable ride through the fabric of space-time. Here's what happens when a star dies. For massive stars, death comes with a bang. When a star exhausts its nuclear fuel, it collapses under its gravity and explodes in a supernova, lighting up the galaxy with an incredible burst of energy. The remnants of a supernova can form either a neutron star, an incredibly dense object packed with neutrons, or, if the star was massive enough, a black hole, an area of space with gravity so strong that not even light can escape. Smaller stars, like our Sun, leave behind a hot, dense core called a white dwarf, which gradually cools over billions of years. The material ejected during a star's death enriches the surrounding space with heavy elements, which can later form new stars, planets, and even life. This cosmic recycling is essential for the evolution of the universe. The outer layers of dying stars often create stunning nebulae, colorful clouds of gas and dust that light up the cosmos. Famous examples include the Crab Nebula and the Ring Nebula. Ever wondered why you stay firmly on the ground and why planets orbit stars? It's all thanks to gravity, the invisible force that holds everything together. Gravity is the force of attraction between objects with mass. It's what makes apples fall from trees and keeps the moon in orbit around the Earth. Imagine the Sun as a massive magnet. Its gravity pulls planets into a delicate dance, creating our solar system. But it's not just stars and planets. Gravity's reach extends across the entire universe, shaping galaxies and even influencing light. Albert Einstein took gravity to the next level. He showed it's not just a force but a curvature of space and time. Massive objects like stars and black holes warp the fabric of spacetime, creating the gravitational pull we feel.
Have you ever seen the night sky come alive with swirling colors? That's the Aurora Borealis, also known as the Northern Lights, putting on a mesmerizing show. These stunning lights occur when charged particles from the Sun collide with Earth's atmosphere, creating brilliant displays of green, pink, and purple. Best viewed near the polar regions, the auroras light up the skies in places like Alaska, Norway, and Canada. Imagine standing under a curtain of glowing lights that seem almost close enough to touch. Once thought to be spirits or omens, we now know that the auroras are a beautiful blend of solar winds and Earth's magnetic field. But even with the science, they still feel like pure magic.
Here's what would happen if you fell in a black hole. As you approach a black hole, you'd encounter the event horizon, the point of no return. The black hole's gravity is so strong here that not even light can escape. The view would become increasingly distorted as space-time bends around you. Crossing the event horizon, you'd experience a phenomenon called spaghettification. The immense gravity stretches you into a long, thin shape, like a noodle. It's a one-way trip with no return. Time behaves strangely near a black hole. From your perspective, you might see the universe speeding up, while an outside observer would see you frozen in time as you cross the event horizon. At the center of the black hole lies the singularity, a point where gravity is infinitely strong and space-time curves infinitely. Here, the laws of physics as we know them break down. Entering a black hole remains purely theoretical, as no one knows for sure what lies beyond the event horizon.